Hello, this presentation is titled Streamlining ChatGPT Code Generation and Narration Workflows. This is a Raku-centric presentation. My name is Anton Antonov. Today is April 10th, 2023. So very quickly, what is this about? I'm going to evaluate this OpenAI mode cell. The cell has the specification, generate Raku code for iteration over a list of numbers and converting them to strings. So automatically, after I evaluated this cell, we got this Raku external execution cell, which was also executed, and we got the result. So the rest of the presentation is just elaboration of how is this being done. So here we import this Mathematica package, OpenAI Raku mode. Raku mode is a paclet which is hosted in the Wolfram language paclet repository. You can see the other packlets being used here. I should make a paclet for this OpenAI Raku mode at some point. So here we start a Raku session. We connect to this Raku session with 0MQ. You can see it here. And with this command, I'm converting this notebook into OpenAI and Raku mode. And there's some additional options are being set up here. It is important to select the correct model for code generation. At this point, we're using relatively powerful model, Text DaVinci 003, which is for text completion. Other models can be used, which are cheaper and faster. I'm not sure how well they work with Raku. All right, so how does this work? So first of all, if you press Shift/ or vertical line, you get this Raku cell, and if you use exclamatory mark Shift1, you get this OpenAI cell. So the user input is being placed, say, in a Raku cell. There is a function called Raku input execute. Then the Wolfram language kernel communicates with the Raku session over 0MQ. There's a package or module in Raku called text code processing, which facilitates this type of executions. And after that, the result is being placed in the output cell. So with OpenAI, more or less the same workflow. It's just we're using an OpenAI link packlet, which is a Wolfram language packlet, and OpenAI servers instead of Raku, which is here. Now we can facilitate the output of OpenAI to become also an input to be executed automatically. This is what is happening here. All right, so this I'm going to demonstrate this. So first I'm going to put this epilogue to identity for this function. This is the execution function from OpenAI. And now when I execute this command, Raku code for transforming a list of numbers into their squares, we get Raku code, but it's not necessarily convenient to execute. I mean, you can see it being a string and so forth. So if I say that the epilogue is cell print and run Raku, we're going to get a Raku cell, and then there's going to be an attempt to run the code. This code has some deficiencies, presumably minor, and now it's running. And if I kind of fix this, then we get some meaningful result, more or less what we requested. All right, so this can be done for other programming languages, like say Python. Obviously, you can do it for Mathematica. I'm not going to do this, but yeah, I mean it is convenient that in Mathematica, Mathematica notebooks, we have this external evaluator cells. And you can see we have a variety of languages here. It's in my to-do list to put Raku into this external evaluation. Right now, Raku has its own standalone type of Raku cell being added. So back to Raku stuff. So let me dictate here, and I'm going to make a new OpenAI mode cell. I'm going to dictate Raku code for making a hash between the letters A and C in the corresponding integers. So I'm evaluating this. What you see here is that it's actually completion. 1 and 3, it's a completion for this statement here, which is actually correct. So this is the code we're trying to do. Let me actually do this again. Maybe we'll get somewhat different results. Again, I'm kind of not really, but it also depends how much the temperature of the generation result has been set, and I'm using a very conservative temperature. All right, I'm going to do something else here. I'm going to generate some more code with dictation. Raku code for plotting the function sine of x between -2 and 10. So this is actually good, except we don't see plot. If I say Mathematica, what is going to happen? So this actually did produce valid Mathematica code, but it's not, because I said that I want this to be evaluated to Mathematica, to Raku. That's why we didn't get the actual running result. If I do this again, with the proper setup here, we get this plot. All right, so right now I'm using ChatGPT 3.5, which is trained up to, I think, July 2021. So some of the more recent developments of Raku packages are not reflected into the training set of the models we're using here. So code narration, very interesting. Yeah, let me remove this. So again, I'm going to change the epilogue of this cell to be identity, and so here I'm asking describe the Raku code of converting the numbers between 0 and 29 to strings, and more or less this is what is happening. It seems to be pretty relevant and pretty helpful. All right, so let me go to the web and get some other Raku code. Like, say, let's take this one, this recent Raku post about Toeplitz matrix, I think, or something, I forgot. Anyway, so ideally we're going to get some result which explains the scores, and we can see pretty detailed example, and it seems to be relevant, and it seems to be narrating it fairly well. So very conveniently, the way in this blog post the code lines were marked, we can actually follow this here. I haven't experimented that much with other types of code. I know that it works well for, say, Mathematica code. If I try to convince you about this, like, say, let me do another cell, and let me bring some Mathematica code. For example, let me see, I'm going to get this, and I'm going to say describe again, this is actually pretty good. I would say I would have expected more narration for the actual hypergeometric functions, and I think this is what is happening here. All right, so there's some related work, and maybe it's a good idea to see these presentations about the OpenAI mode demo, which is in general for using this kind of OpenAI mode cells in Mathematica notebooks, and then specifically generating code with the OpenAI mode. There is another related type of work, how we actually connect Raku and Mathematica and Wolfram language. So I've documented this and given presentations about it in the past. And there's some future work to be done. I would be more interested to do documentation and comprehensive examples, but some productization of this OpenAI and Raku mode functionalities needs to be done. Would be nice to replicate these functionalities in Jupyter. There's a Jupyter kernel module in Raku, and so when I say replicating the functionalities in Jupyter, I mean to do what I was showing in Jupyter. All right, this was it. Thank you.